Hello everyone, this is Prashanth Reddy, Department of Mechanical Engineering, Institute of Aeronautical Engineering. We are going to discuss about thermodynamics. Today's topic, we will discuss the basic principles of thermodynamics and introduction to thermodynamics. And if you go for thermodynamics, it is evaluated from two different words. One is thermo and dynamics. So it is evaluated from the two topics called thermo and dynamics. So as of known, if we call a thermo means it is a heat function. So if anything which is deals with the heat, we call as a thermal. So that is called a heat function. And dynamics is, as we know that dynamics is a function, that means it is applied as some amount of force on an object, moving object. So we call as a dynamics. So the meaning of this thermodynamics is, by using a heat energy, if any mechanical work output if you're getting, that systems we call as a thermodynamic systems. Okay. Now what are the principles involved in that type of things we're going to discuss in thermodynamics. So thermodynamics is a basic principle oriented subject, and this is entirely depends only based on heat applications, heat energy things, right? If you go for a definition of thermodynamics, it is a branch of science, a phenomenon of energy and related properties of matter, and especially of laws of the transformation of heat into other form of energy and vice versa. That means it is convert the heat energy to the work energy, or it may be use work and convert into the heat energy. That type of systems is deals by thermodynamics. So we can also call as thermodynamics is a science of energy transfer and the physical properties of substances. And it is based on observation of the thermodynamics evaluated in such a way that it is based on observations of situations. By observing the situations, the thermodynamics slowly come into picture, and it is also laws are defined by using a observation of situations. So this is called thermodynamics. So where we use this thermodynamics? What are the applications of thermodynamics and how we use in real life and day-to-day life where we observe this thermodynamics? So we'll explain one by one. Steam and nuclear power plants. So one is steam and nuclear power plants, and second one is internal combustion engines, gas turbines, refrigeration and air conditioning, and gas dynamics, jet propulsion systems, compressors, and chemical processing units or any direct energy conversion units. There we use thermodynamics. And we'll discuss one by one. What is steam and nuclear power plants? So we know that we are getting a electrical energy to the home means that there is some mechanical energy to be conversion unit, right? There is some mechanical device, so which convert one form of mechanical energy to the electrical form of energy. That means, generally, if you go for outside wall, there is a turbine. Okay, the turbine is coupled to the generator, so that the mechanical energy is developed by the turbine and electrical energy developed by the generator, so that while we couple the turbine and generator, we'll get some amount of electrical energy from this one. So that energy we are using in our day-to-day life. So here, what is the importance of nuclear and steam power plants means? So nuclear energy and coal energy, we used to develop some amount of thermal energy. So what is the function of nuclear and steel means? So there is a generally in any nuclear and power plant, there is a boiler is like this one. Okay, so this is we call as a boiler. Okay, we are supplying some amount of heat energy to this boiler. So some amount of Q amount of heat to this one. So while we are supplying the heat to this one, inside there is a water content or some substance which is there. So which is get heated and slowly get evaporated. So the evaporated substance is we pass through the pipelines and touches to the turbine. So we touches to the turbine. So what turbine done? So it is use the energy of whatever we generated the power of steam by using the steam power. It is convert the mechanical energy. So the turbine work is that it converts steam energy into the mechanical energy. So now we couple this turbine with a generator. Okay, so the generator is generate the electrical energy. This is a basic function of any steam power plant. Okay, so The energy supplied is the most important form, so that we are generating a steam, so that we are to generate that steam we have to supply some amount of heat energy. That heat energy we can either get it from the coal supplies, or that means burning of coal, or maybe of doing some chain reaction of nuclear fuels. Okay, this is a stage of generating of steam and conversion of mechanical energy into the electrical energy. So this is a place we use thermodynamics. And not only that one, we also use thermodynamics in internal combustion engine. So what is internal combustion engine? See, in a day-to-day life, while in a transportation of a road transportation, seaway transportation, rail transportation, or any in a air transportation system, we use internal combustion engines. So actually, what is internal combustion engine means? So, right, internal combustion engines. So what happened means, just I take a basic example of internal combustion engine, how generally we use outside. So internal combustion engine means, that is maybe we can also call as automobiles in outside. So internal combustion engines. So I give the example for the internal combustion engine. So I take an example of piston cylinder as an example of internal combustion engine. So this is a piston. So this is you call as a piston, and this is you call as a cylinder. So piston and cylinder. So inside this piston and cylinder, we supply the some amount air and fuel. We supply the air and fuel. Once we supply the air and fuel, what happened? Inside we supply. Once we supply together, it is mixed together, and we give some amount of spark energy to this one. Either maybe by using a spark plug, or maybe by using a compressible ignition system. Once we get once we supply the spark, it will ignite, and the ignition forces pushes this piston to the downward, and whatever amount of force with that force, how much amount of force it is pushes, that much amount of mechanical energy stored in this flywheel. So now we club this flywheel with the automobile wheels, okay, automobile wheels, and we run the automobile. Okay, so whatever we see the day-to-day life, automobiles like cars or bikes, whatever we see, it is runs on the principle of the piston and cylinder mechanism, and it is also called as internal combustion. Why we call this as internal combustion means, the combustion is happened in a internally by on a closed condition. That's why we call this as a internal combustion engine. Okay, so one more example for this one is gas turbines. So gas turbines also called one type of internal combustion, but where we use this one is by using initially we compress the fluid. That means initially we compress the gases. That means any air or any substance. That means compressor it is. This is a turbine, and there is a combustion chamber. And we supply the air from here, and initially we compress up to certain extent of pressure. Then we supply the same through the combustion chamber. Then we supply this to the turbine. What happened here is, the compressed gases, when it is mixed with some amount of fuel, then it attains some amount of energy. That energy we pass through the turbine, and turbine will rotate. So we curve this turbine to the any form to generate the power. That means to generate the electrical power, or maybe to generate mechanical power. That means aeroplane applications, like aeronautical applications, we can use this power. So this is nothing but the gas turbine. So what happened in both the cases is that we use the chemical energy, and in this case also we use the chemical energy, and we convert this chemical energy into the mechanical energy. Right? We are giving us amount of combustive system. That means we are making into the burn, and we convert that one into the mechanical energy. So the meaning is this one. It is, we are using a heat energy and convert it to the mechanical form. So this type of system we call as thermodynamic systems. And refrigeration and air conditioning. Last three cases, whatever we discuss, we use the heat energy and we convert it into the mechanical energy. But now, if it is a system of refrigeration system, we use mechanical work and we make into the heat energy. That means, so in a refrigerator, what we have a motor, okay, and this motor is coupled with some compressor. Okay, so compressor, what it is do, it compresses the gases, and it passes through the condenser, then it is go to the expansion valve. After that, evaporator, come back to the again compressor. So what happened here is I am using some mechanical energy and I am compressing a refrigerant, nothing but any gaseous refrigerant or liquid refrigerant, anything. I am making a pressurized refrigerant and passes to the condenser. So here condenser work is that it is exchange the heat between the inside refrigerant to the atmosphere. That means it is releasing the heat to the atmosphere. And the work of expansion valve is that it is expanding the substances. That means it see previously in a compressor what happened, it is in a high pressure conditions, right? The pressure is I am increasing in this case, now I am decreasing the pressure here. Due to the drastic decrease of pressure, what happened, the temperature inside the refrigerant is goes down. That means temperature drops drastically. That temperature we use to cool the refrigerator. So previous two cases is that I am using a thermal energy, I am converted to mechanical energy. This is a case of using a mechanical energy and converted into the heat energy. That means absorbing the heat energy. Okay. So this is a one more gas dynamics. That means whenever you are running an aeroplane or some aeronautical applications, there is a aerodynamic drags are applied there. So that means, so yeah, I have some rocket type of system. If you take example, okay, while it is moving, there is a aerodynamic drag is happening there. So the how drag forces are acting on that one. That means these all the things are also discussed by thermodynamic systems. And jet propulsion, that means propulsion system of jet engines and also air compressors. This is also one more example of so air compressor also one of, that means we use a mechanical energy. Okay, we use a mechanical energy, we compress the air, that means air compressor, right? We use a mechanical energy and we compress into the air, that is called the compressor. And we also have chemical processing units. So there are some chemical elements which while they are reacting with each other, there is some amount of heat is releasing. So we have to dissipate heat to the surroundings, so that we have to remove the heat from that one. That is the cases also we use thermodynamic application. That means we use thermodynamic systems. This is also come for the one of the application of thermodynamics. Okay, and energy conversions. So convert the one form of energy to the other form of energy. There we also have application of thermodynamics. These are the examples for the thermodynamics. Now I am taking a small day-to-day life example. There is a hot cup of coffee, okay, which is observe the temperature is something 72, take sometimes 100 degrees approximately. Take a range of that one. Okay, so if I keep that coffee outside, what happened? There is an outside cool environment. Nothing but atmosphere is having a temperature range of 20 to 30 degrees. So this is a higher temperature range. This is a lower temperature range. Generally, what happened in a heat is generally exchange the heat between the lower temperature to higher temperature. That means heat is travel from the higher temperature region to the lower temperature region. So same hot cup of coffee having a higher temperature condition, and it is transfer the heat to the atmosphere by the walls of the coffee cup or by maybe the from the top surfaces. Okay, it is release the heat. Okay, so it is also release the heat. Nothing but now the environment surrounding to this cup of coffee get heated up, and the substance inside the coffee, that means inside the cup, is get cooled up. Okay, that is the thing we have is the day to day. These all conditions comes for the thermodynamic examples. Okay, so after this, there are two specific things we have to discuss. So while we going to deep into the thermodynamics, one of the important parameters are macroscopic approach and microscopic approach. So what is macro and micro? By the name itself, we can understand that if any substances or if any studies, if we do in a microscopic level, that you call a microscopic approach of studies. If any things, combination of many microsystems, if you deals with that one, you call as macroscopic systems or macroscopic approach. So simple. So for example, I have a compressor example. I will take an example of compressor. So compressor is generally we notate in thermodynamics like this one. So in a compressor, what happened? I am supplying the air from this one and it get compressed and released from this one. This is inlet, this is outlet. So we can see this type of compressors in outside also. We have to fill the air in automobile tides, also to fill the air in some air balloons, some places. We can see that this type of compressor systems. So what the function of compressor is, just heated, just to compress the gases and send it. So if you want to study about the compressor type of systems, we just read how much amount of pressure inlet we are giving, how much amount of pressure outlet I am getting. Okay, how much amount of temperature inlet I am giving, and how much amount of temperature rise due to that one, and what is a volume while giving inside, and what is a volume is a final volume we have outside. This is the only things we have. So we are not concentrate on individual particles of air. So we are not concentrated of any individual particles of air. Just we take the input parameters, just we take the output parameter, just we deal overall system of the compressor. That means we only discuss the overall system of that. So that type of systems come for macroscopic approaches. Right? We are not discussing any individual particles. In a microscopic approach, what happened? Individual particles of air, small particles of air, we have to take care of that one. Okay, if you study like that, that you call as a microscopic approach. The definition also is like this one. In the macroscopic approach, a certain quantity of matter is considered without the events occurring at the molecular level being taken into account. That means in a molecular level, how it is happening, we are not taking into account. But from the microscopic point of view, the matter is composed of many rates of molecules. That means very small particles of molecules we are concentrating on there. So this is the both difference between the microscopic and macroscopic approaches, right? So once we complete with the microscopic and macroscopic, now we have to know what are the basic definitions inside the thermodynamics. If you go for the basic definitions of thermodynamics, so we know that thermodynamic systems is defined as a quantity of matter or a region in a space upon which attain is concentrated in an analysis of problems. Okay, anything, if you are dealing with some problematic point of any heat substances, we call it a thermodynamic system. When you deal with the thermodynamic system, it have generally we have system. Okay, I have a system. Surrounding to this system, I have a boundary. This is system, and the boundary, that means, yeah, this is a boundary, and the outside of this one we call as a surroundings. So what happened? In every system I have a system. Okay, whatever the matter, it is have some system. We call in terms of thermodynamics we call as a system, and the system have a boundaries. That means walls of that system, and it have a surroundings. In any thermodynamic system, if you want to study about that one, you have to take consideration of all these three. Okay, for example, I'll take a small example. Okay, so I'm taking example of some boiler, turbine and condenser example, what we discussed just before. Okay, I have some boiler. Okay, inside boiler I have a water. I'm giving us amount of heat input to this one. I'm giving us amount of heat input to this one. Once I give the heat input water bit, it generates the steam. Okay, generally what I do, if I have a steam, I touches to the turbine. Okay, so if I touches to the turbine, what happen? If I touches to the turbine will rotate. That means it converts the one form of, that means steam energy to the mechanical energy. Okay, and generate some amount of mechanical energy, right? So once this steam is touches to the turbine, what happened? It is after this, it will come out from the turbine. Okay, it come out from the turbine. Once it is come out from the turbine, we have to cool this steam to the room temperature. Okay, how to cool this one to the room temperature? or may not be room temperature. We have to cool up to certain extent of limited temperature. Then we supply the same water again back to the boiler. Okay, so what happened is, here I am increasing the temperature. That means here I am adding a heat. Here I am removing the heat. So to remove the heat effectively, if it is a surrounding temperature is very low, that means temperature of surroundings is very low, then I can easily remove the heat effectively. That means the change of heat I can drastically change. Okay, but if the temperature of surroundings are higher, nominally higher, if you take, then the rate of heat transfer, that means rate of change of cooling, it is low. So that's why the surroundings temperature also very, very important if you have to study about the thermodynamic systems. So that's why whenever you have to study of any thermodynamic system, you have to study about the system. You have to know the boundary conditions of that one. You have to know what is the surroundings of that. Okay, take this same diagram indicate. It is a system. Okay, it is a, so here the boundaries, if you take, that boundary may be of fixed boundary or maybe of imaginary boundary. That means it is a maybe imaginary substance we can take. Okay, that it may be of fixed boundary or imaginary boundaries. Okay, may not be always fixed boundaries, and it have also have a surroundings to each. Right. State of system. A state is a macroscopic condition of thermodynamic system as described by its particular thermodynamic parameters. State of a system, if you want to discuss, it is specifically we say that what is a particular thermodynamic parameters. Nothing but we have thermodynamic few properties like pressure, temperature, density, compositions, and volume. These are the few thermodynamic properties we have. So depends on this thermodynamic properties, we have to discuss what is a condition of the thermodynamic system. Okay, so this is the next. When you take the examples of thermodynamics, and if you go to the definitions of thermodynamics, we have to discuss 3 specific types of systems. So when so just before we discuss about the system, right? System have boundary and it have a surroundings, right? This we discussed. But if you go for types of systems, we have a 3 basic definition of systems. One is open system, other one is closed system, another one is isolated system. We'll discuss one by one. So open system. So what is open system means? Simple. I take an example of nozzle. I take some example of nozzle. It is having a shape of this one. So what happened inside the nozzle? The mass of, I am supplying some amount of steam from that nozzle. Okay, I am getting some amount of steam out from this one. So I am supplying the inlet. This is if you take inlet. This is outlet. So I am giving some amount of input of steam. I am getting some amount of output from that. Right. So what happened here is, if I take a nozzle. So here there are a few properties, like inside there is some P1 amount of pressure and V amount of volume. Okay, V1 and small V1 amount of velocity. That means if you take, it has some amount of kinetic energy, K1 amount of kinetic energy. Okay, next. Because it is a nozzle, what happened? The velocity at a second goes on increases. Okay, that means kinetic energy we can observe that it goes increases. Nothing but we are converting a low amount of kinetic energy to the high amount of converting. That means K1 greater than K2, Ke1 greater than Ke2. Okay, we are converting this one, right? So what happened? Energy is I am converting one form to other form. That means a lower grade to higher grade. And also what happened here is, here some flow of fluid will happening. Okay, from inlet to outlet there is a flow of fluid will happening. That means what happened here is I am transferring the mass as well as energy. If the system is transferring both mass and energy, that type of systems we call as open system. Okay, if any system which is transferring both mass as well as energy, or it is interacting with both mass and energy. That type of system we call open system, right? So next, there is a second system is that closed system. So example I am taking, if I am taking example of electrical bulb, okay, so I am supplying the positives and negative to this electrical bulb. So while I am switching on this one, the electrical bulb will glow up, right? It will glow up and it gives us amount of light energy, right? So what energy I am giving? Electrical energy I am giving, light energy I am getting, right? So only energy interactions are happening here. There is no mass interaction, right? I am giving an input of electrical energy, I am getting a light energy output. So only energy interactions are there. That type of systems I call as closed systems. If any system only energy interactions are there, no mass interaction are there, that type of system I call as a closed systems. So there is a one more system class, isolated system. If the system does not transfer the energies, that means there is no interaction of energy, there is no interaction of mass. That type of system we call as isolated system. Simple example for this one is a thermo flask which contains some hot fluid in this one. Okay, so some thermo flask which is insulated from outside. Okay, which is insulated from the outside. So there is no energy interactions, there is no mass interactions. That type of systems we call as a isolated systems. Okay, so in a thermodynamics, basically these three type of systems we generally come across. So addition to this one, there is a one more system I have, but not comes for this classification. But generally we have fourth one called adiabatic systems. So in a closed system, what happened? Only energy interactions are there, no mass interactions are there. That type of system we call closed system. But in adiabatic system, only mass interactions are there, no energy interactions are there, then I can call as adiabatic system. The example for this one is, so in an air conditioning system, we see the copper pipes is winded with some rubber tubes. That means inside the copper tubes, what happened? The refrigerant is flowing over the copper tubes. That means cold or hot fluid, that means mostly cold fluid of refrigerant is flowing over the refrigerant pipelines. So if the cold fluid is flowing, if it is interaction with the outside world, what happened? There is a heat exchange will take in place. That heat is, that means the cooling energy, that means absorption of heat takes place there itself, and we are not getting any cool effect to inside. So that's why what happened, they are wound with some rubber tubes or any insulated things, insulated materials or insulated tapes. So due to that, what happened, inside that pipe only the same amount of cool refrigerant is flowing over that, but the energy is, we are not interacting with the outside. So there is no interaction of energy to the outside. But what happened, there is mass interaction that way. The system which is having only mass interaction, but there is no energy interaction, that types of system we call as a adiabatic systems. But this is not come for this type of system, but this is a most somewhat related, but not exactly of classification of this type of system, right? So just I'll recall again. Open system, if there is a mass and energy interactions are there, that type of system we call as an open system. If only energy interaction is there, that we call as a closed system. If no mass, no energy interactions are there, that we call as isolated system. And there is a fourth classification we add, that is adiabatic system, which only mass interactions are there, no energy interactions are there, that type of system we call as a adiabatic system. Okay, right. So the examples are, we can say, shown here. This is a closed system, only energy in, energy out will take place, but there is no mass interaction. In an open system, mass in or mass out will take place, and energy out, energy in, energy out will take place. That we call the open system. Okay, in an isolated system, it is fully restricted with outside wall, so that there is no interaction of mass. That means there is no chance of interaction of energy or mass. That we call as a isolated system. Right. Next, in go for a deep definitions of thermodynamics, there is a property of systems. Okay, so what is a property, or what is property of a system? Okay, there is a two types of properties generally we have. One is intensive properties and extensive properties. Okay, so what is property before going to the intensive or extensive? So every system has certain characteristics by which its a physical condition may be described. Okay, to describe some system, we have some amount of physical conditions. Those physical conditions we call as volume, temperature, pressure, or sometimes we can also call it density. These are the such type of physical characteristics. Okay, these such characteristics are called properties of the system. Okay, to define any system, what is the temperature inside this one? What is the pressure acting on that one? What is the volume of that substance? What is the density inside this one? If you are defining of any system, you have to take care of these all systems. That the take care of things we call as a properties of the system. Okay, how it is existing at that particular time we call as a property. Okay, there are two types of properties of systems are there. One is intensive property, other one is extensive property. So I'll give an example for this intensive property to easy understanding of this intensive and extensive. Okay, I take the container. Okay, the container have some gas inside that one, which is having a mass m. Okay, and it have a volume v. Okay, have a density rho, and at a temperature T, and at a pressure P amount of pressure. So there is some system. In that system, that means there is an example, take some liquid or any gas. Example, you take any liquid or gas. So liquid or gas having a mass m, volume v, pressure P, temperature T, and okay, density rho. Example to take. Okay, now what I am doing is I dividing the system into two parts. Same system, I divide into two parts. Okay, I am dividing this system. Okay, I am taking this is the first one, this is the second one. So assume this is a container. I divide this container into two parts. That means in between I kept some partition. Now what happened into this system? First, here because of I am dividing into two parts, exactly two parts, the mass will get equalized. That means in the first part it is m by 2 and the second part it is m by 2. Okay, and volume also divided into half, that means v by 2 and v by 2, right? But for the pressure is not divided, it is shades, that means same amount of pressure acting there and here. Okay, and what is the temperature? Temperature also not divided into by 2, it is also same at the both the conditions. And the density also same at the both the cases. Okay, right. So these two are what happened, it is changing by the changing of that system. That means if I divide into two phases, that it is divided into two parts. Okay, okay, this type of systems you call as extensive properties. This type of properties you call as extensive properties. These properties you call as a intensive properties. Okay, so simple, I have some container, I divide the container into two parts. Okay, after dividing, what happened? Mass become equal at the both the containers, volume become both equal at the both, but pressure, temperature, density is the same at the both the conditions. Okay, which is nothing but it is pressure, temperature, density. These type of properties does not depends on mass or volume. Okay, but mass and volume depends on the mass. Okay, so from this one we can say that intensive properties are those properties which have a same value for any part of the system, or those have properties that are independent of mass or volume of a system. Okay, example for intensive properties we can take in as a temperature, pressure, density, okay, and specific volume, specific enthalpy, specific entropy. These things we can call as, that means specific volume, specific enthalpy, specific entropy. This comes for the example for this intensive properties. That means which is does not depend on mass or volume of a system, right? What is extensive? Any substance which depends on mass or volume, that we can call as extensive properties. The example for these extensive properties are mass, enthalpy, volume, energy, entropy, these are comes here. Okay, here also enthalpy, entropy are there, but these are specific enthalpy and specific entropy, but these are enthalpy and entropies. Okay, direct enthalpy and direct entropy, but these are specific enthalpy, specific enthalpy. So units for this one is kilojoule per kg, units for entropy is kilojoule per kg Kelvin, but for this one it is a unit is kilojoule per Kelvin. For this one unit is kilojoules. Okay, these are called the two different types of properties called intensive and extensive properties. Next, there are two more things we have to go on, need to know about the basic definitions of thermodynamics. One is path, other one is cycle. So I'll take the example of this one and I'll define what is path. So take example, assume this is a piston and cylinder. Initially it is the piston is at this position. Okay, now by applying this amount of force from this end, okay, and it will come to the position of this one. It is come to the rest position of this one. Now what I am doing, I am decreasing the volume. Okay, so nothing but initial volume is this much and the final volume reaches to this much. The overall volume is from here to here. Okay, nothing but the gas is having this much amount of volume only. Right, so here what I am doing, slowly I am decreasing a volume, nothing but it is following some amount of process or it is following some amount of path. Okay, so with respect to this movement, if I measure the pressure inside that one, if I measure the pressure and draw the graph to this one, you get the graph is like this one. This graph is follow the some path. Okay, it follow the some amount of path. So that is nothing but if all the changes of system of the changes of state of system are plotted, then a line joining of changes of states of the system is known as path. Nothing but at each individual position, if you change the volume, if you measure the pressure at each individual points, okay, if you draw some dotted lines over this one, okay, if you draw the line over the dotted lines, you will get the some line, that line you call as a path. Okay, so there is one more thing called cycle. Cycle is nothing but it is following you can call it as a compressive process, and if you expand this one, or if you by adding something, if you expand again by doing some thermodynamic property and expand again, it come back. So initially it is going this way and it is come back again. So this is you call as a cycle. The whole thing you can call as a cycle. That means where it starts and move to some position and come back to the original position, we call it as a cycle of the system. Okay, so these two are path and cycle of a thermodynamic system. Right. Next, not only this one. If you observe any thermodynamic systems like Rankine cycle, or I take some example of Rankine cycle. If it is a Rankine cycle, it is a cycle is to be like this one. So yeah, so Rankine cycle is to be like this one. Okay. Nothing but looking to be, sorry, it is reverse. Right. So it is started at this position of 1 and goes to the second position. So this is called as a condensation, and from second position to it reaches to the third position. This is nothing but pumping, and from the third position to it reaches to fourth position. That is called as a addition of heat. Nothing but this do the work under boiler. That means adding of heat, and once I add the heat, touches to the turbine. That means it will flow over the turbine. This is called a turbine. Then again come for the condenser. Okay, this is a system's equal as a. What happened here is it is a following some cyclic process. So this is called as a system, and in that it is a cyclic process. So that's why you call this type of thing is Rankine cycle, because it is a cyclic process. Okay, so Rankine cycle. Okay, this is a very basic introduction about thermodynamics and its properties and types of properties and a cycle and a path. These all comes for the thermodynamic introduction part.
Like, share and subscribe. Hit the bell icon for more updates.